Hi everyone. So today we are going to learn about thermochemistry. So the meaning of thermochemistry is the study about the heat changes in chemical reaction. So before we go deeper into this topic, I want to let you know that today we will cover about endothermic and exothermic reaction along with their applications. Okay, so now let's start the lesson by knowing what happened during the chemical reaction. So do you know that in any chemical reaction, chemical bonds are either broken or formed? The rule of this statement is that when chemical bonds are formed, heat is released, and when chemical bonds are broken, heat is absorbed. So it shows that when molecules want to stay together, so the formation of chemical bonds between the molecules require less energy compared to breaking the bonds, which require more energy if the molecule wants to stay together. So the result of this reaction is the heat being absorbed from the surroundings. So this is what we call as the change to the potential energy of the system. Okay, so next, when the heat energy is absorbed or released under constant pressure, we call this reaction as the enthalpy. While the change of enthalpy from the chemical reaction is the enthalpy of the reaction, or we can write it as the delta H. So for better understanding, let's look at the example of the process of hydrogenation of the propane gas to the propane. Okay, so during the hydrogenation of propane to propane, propane gas actually will react with the hydrogen gas to form propane gas. So to create this reaction, firstly we have to break the carbon double bond in the propane and the hydrogen single bond in the hydrogen gas. So as I said just now, breaking bonds between atoms requires energy. So the stronger the bond, the more energy it takes to break the bond. So to form the product of propane gas, we need to create new bond, which is carbon single bond, and we need to create a single bond of hydrogen with carbon. So the opposite process of breaking the bond, which is forming bond, always releases energy. So it concludes that the stronger the bond formed, the more energy is released during the bond formation process. So for your information, in this hydrogenation process, the newly formed bonds releases more energy than was needed to break the original bonds. So it resulted in lower potential energy than the reactants. This means that the enthalpy of the reaction is negative. From this, we know that the enthalpy of the reaction is actually the difference between the potential energy of the product bonds and the potential energy of the reactant bonds. To be more specific, the reactions where products have a lower potential energy than the reactants, such as the hydrogenation of propane, are actually exothermic reaction. So this concludes that reactions where products have a higher potential energy than the reactants are endothermic reactions. For your information, in an exothermic reaction, the released energy actually doesn't simply disappear. Instead, it is converted into the kinetic energy which produces heat. This resulted as an increase in the temperature as the reaction progressed. On the other hand, during endothermic reactions, which often require the addition of energy, must be done in a higher temperature. To understand more on this matter, let's look at few examples of exothermic reactions and endothermic reactions. Firstly, do you know that exothermic reactions are important in technological applications, as the released energy actually can be used to perform physical work on an external system. For example, the internal combustion engine of a standard car. So the heat released from the combustion reaction of gasoline will exert a physical force on the engine's pistons, which then will cause them to move. So then the piston will convert that heat energy into mechanical energy. So the mechanical energy then will drive the turning of the car's wheels. Not only that, exothermic reaction also a common in explosive substances. To be more specific about the combustion reaction, let's look at the combustion reaction of natural gas methane. So during this reaction, the hydrocarbon, methane and oxygen bonds of the reactants are broken. So since the double bond of the oxygen, which is the reactants, is much weaker than the single bonds of the carbon dioxide and water, which is the product, the reaction will actually releases a large amount of heat into the environment. So not only that, the heat produced is also large enough to self-catalyze the reaction. So normally combustion will continue until there are no more reactants left. So we can conclude that depending on the amount of oxygen available, a combustion reaction can be complete or incomplete. So in a complete combustion reaction, there is enough oxygen to produce a molecule of carbon dioxide per unit reaction. So in a incomplete combustion, a lack of oxygen will result in the production of carbon monoxide, which is a poisonous gas. So the products of incomplete combustion can also react with gases in the atmosphere, which then will create nitric and sulfuric acid rains. Next, nuclear fission is another type of special examples of exothermic reactions. So during nuclear fission, a nucleus of a heavy atoms splits into pieces, which then create a lighter elements and release energy. So during this reaction, energy is released in a form of heat, kinetic energy, and a gamma photons, which is a form of high energy radiation. So nuclear fission reactions are extremely powerful and are the mechanisms underlying nuclear weapons and nuclear reactors. So unlike other kinds of exothermic reactions, which involve the breaking of chemical bonds and the formation of new chemical bonds, fission reactions are actually the result of breaking nuclear bonds, which is the bonds between the particles in an atomic nucleus. So these bonds are extremely energetic. So when they are broken, they release a large amount of energy. For your information, nuclear fission is a form of nuclear transmutation, as the products are different elements than the original atom. Generally, the nuclei produced are of similar atomic size, normally at a ratio of 3 to 2 atomic masses. So unfortunately, these products are almost always very radioactive, which will give rise to the problems when we store the waste products of the nuclear fission reactions. It means that some elements, especially high atomic number elements, will undergo spontaneous fission. But normally, fission requires an external input of energy. So, in nuclear reactors and bombs, heavy atomic nuclei are bombarded with free neutrons which break the nucleus apart. So, the resulting fission reaction releases more neutrons. So, when there is enough of the reactant available and enough neutrons in an enclosed space, a self-sustaining nuclear chain reactions will occur. So, this is a dangerous thing. So, after that, of course, the process of endothermic reaction is totally different from the exothermic reaction. So, in endothermic reaction is actually a type of chemical reaction in which energy is consumed in the form of heat, so that the product obtained has an energy greater than the initial reagents. So the term endothermic has a Greek roots endo, which means inside, and thermos, which means hot, which specifically means it will absorb heat. So to understand how an endothermic reaction works, it is necessary for us to fully understand the concept of enthalpy that I taught just now. As the resulting products are more energetic than the initial reagents, energy absorption from the environment is required to meet that need. So this process generates a break in the active bonds, and that is when the endothermic reaction occurs. So the energy absorbed in the form of heat has to be taken from somewhere. So in this case, from the immediate environment or environment. So in many endothermic reactions, the process implies a temperature drop. Then, some examples of endothermic reaction is the process of photosynthesis and sublimation process. So during the process of photosynthesis, plants will absorb heat energy from the sunlight and then convert the carbon dioxide and water into glucose and oxygen, while sublimation occurs due to the absorption of heat through solid materials. So solid materials will absorb heat, which then will excite the constituent molecules. The excited molecules will move quickly enough to escape the attractive forces of other molecules and sublime in the atmosphere. So in fact, the same mechanisms drives the evaporation of liquids into gases. Depending on the temperature and pressure, the escape molecules will either melt into a liquid or sublime into a gas. So sublimation is a physical transition of state, so it does not refer to the process by which chemical reactions convert solid reactants into gaseous products. So combustion reactions like burning wood do not count as sublimation, as the combustion is a chemical reaction caused by the oxidization of reactants. So sublimation requires the input of energy and is thus an endothermic reaction. So combustion is exothermic reaction, like I said just now. So that is the difference between the sublimation and combustion. Next, for your information, during the process of chemical reaction, there is actually exists an intermediate stage where chemical bonds are partially broken or partially formed. So this intermediate stage exists at a higher energy level than the starting reactants. It is a very unstable and referred as the transition state. So the energy that is required to reach this transition state is called deactivation energy. So we can define deactivation energy as the minimum energy required to initiate or start a reaction, and it is denoted by the symbol capital E, activation. For your information, we can use energy diagram to show the relative potential energies of reactants, products, and the transition states. We can also calculate the enthalpy of the reaction and deactivation energy from the energy diagram. So energy diagram for endothermic reaction is totally different to the energy diagram of the exothermic reaction. So in an endothermic reaction, the reactants are at a lower energy level compared to the products. So in other words, the products are less stable than the reactants. The reaction are also in a forward direction towards the more unstable entities. So the overall enthalpy of the reaction is positive as the energy is absorbed from the surroundings. So in the case of exothermic reaction, the reactants are at a higher energy level as compared to the product. So in other words, the products are more stable than the reactants. This concludes that the overall enthalpy of reaction is negative as the energy is released in the form of heat to the surroundings. If you have understand what I taught, so let's end our lesson for today. So I hope that you understand what I thought about this topic today. So thank you, and I hope that we can meet again to learn about other topics.